In this episode of Exploring Rust, we're going to take a look at passing messages and data between threads. My name's John Purcell and I run the website caveofprogramming.com where I sell courses. And as you'll know if you've been following this series of videos, this is basically me learning Rust and then explaining stuff that I've learned. I'll probably make a proper course on this at some point in the future that's, properly organized and where I've double checked everything. But this is a kind of more informal thing where I'm just explaining what I think I've learned to the best of my ability. So in this video, we're going to take a look at passing messages between threads. And you might think, why would you want to do that? But actually, this is something that seems to me to be much more useful in Rust than it even is in most other programming languages. So I'll just explain briefly the motivation for this before we get into the actual code. And if you want to see just literally how to do this, then you're going to have to just skip ahead a little bit. So I'm now programming in Rust every day, and I have to say that I really like it. I'm almost kind of surprised by that, but it's a really interesting experience, partly also because I'm constantly using things like Microsoft Copilot, which is free, or I also use Grok. So if I want to know how to do something, I'll just ask Copilot or Grok, and it'll usually give me an answer that, well, it usually works and is often better than what I could have written myself off the top of my head as a relative beginner with Rust. But often I have to correct the code that it's given me in some kind of a way, or keep asking it different questions to finally get at something that actually works. But nevertheless, it is extraordinarily useful. I have also been using the autocomplete feature in Microsoft Visual Code. Actually, not the autocomplete feature, I do use that, but what I mean is the GitHub Copilot thing that can generate code for you. You just type and it tries to guess what you want to write. And that's really useful. The only problem is that on the free tier, I run out of suggestions in about 3 days. But I do use it when it's free and available to me. And Rust itself, yes, you have to really kind of dot every I and cross every T, but somehow that's actually quite entertaining. It's like a little puzzle that you have to figure out. It is harder than programming in other languages, but the massive advantage is that once you've actually got your program compiling, I find it nearly always just works, seemingly flawlessly. If I wrote some kind of software synth in C, I'd definitely expect to get an absolute ton of bugs when I finally ran the thing, but that doesn't really seem to be the case in Rust. So it's pretty amazing. You've got this difficult puzzle to solve. You've got to figure out how to write the actual code. But when you actually write it, it generally does seem to actually work. At least that's my experience so far with, surprisingly few bugs. So anyway, my problem was that I had a program which had a data model in it, and then there's a user interface, which I'm using something called eGUI for, which writes to the data model, and then there's a thread that creates the sounds, does a software synthesis that reads from the data model. And I found that in Rust, that doesn't work in the way that I might have expected it to, because in maybe Java or C, I could just pass around references to the model, and I might have to do some things with mutexes to ensure that the thread that's actually reading the data doesn't read incomplete data or something. But apart from that, that could be a relatively easy task. However, Rust's ownership rules, which protect you from doing all kinds of things that you shouldn't do anyway, make it a lot harder to do this, to actually have a data model that's quite complex and then pass around references to it, which different things can read from and write to. I found that a lot harder in Rust. And the solution that I found to this is to use messaging, cross-thread messaging. So I have like a kind of entity which I call the update engine, and that runs its own thread. And that actually owns the data model. And then the user interface, so the UI, whatever you want to call it, GUI, whatever, that can send messages to the update engine, and the update engine will then update the model as necessary. the user interface can also send messages, and the update engine will reply with data to actually put in the user interface. Similarly, the synthesizer, the software synthesizer that's supposed to eventually make music, can also send messages to the update engine to get the data that it needs. And this system seems to work, from what I've seen so far, it seems to work really well. You might think, isn't this going to be too slow or something because we're using messaging? But of course, we're not talking about emails here or something like that. We're talking about something that works extremely quickly and efficiently. So I'm going to show you how to do that kind of thing in this video, how to have threads sending messages to each other and even replying with data where necessary. And I'll try to remember how to do this. I've been through it a couple of times. Hopefully I can remember this without looking anything up now. The first thing that we need to do is go to cargo.toml and add a dependency. So there is something that's commonly used in Rust, which I've probably forgotten the name of, but it stands for something like multiple producer single consumer. What would that be? MPSC, something like that, which is often used for messaging across threads. But there's an alternative that's also extremely common called crossbeam, and that's what I want to use here. And the thing I like about crossbeam is that you can have senders or receivers, things that are going to send data or receive data, and you can clone them as much as you like. So you're not actually creating entirely new channels or whatever to send data across. You're just cloning the senders and receivers. You can clone them and then move them into a new thread. You'll see how this works shortly. It sounds complicated, but it seems to save a lot of hassle. So I'm going to set the version of that to 0.5. I'm not really sure how you're supposed to find the latest versions of dependencies, but I guess it's pretty easy to look up. Just Google it or ask Microsoft Copilot or something like that. So now let's put some dependencies that we're going to need here. So I'm going to use crossbeam underscore channel. That's beam, not bean. Crossbeam underscore channel. And what do I want from there? I think what I want is a bunch of things. Well, we want sender and receiver, and I'm also going to use something called bounded and unbounded. I have a feeling there might be one more thing, but I can't remember, so that'll do for the moment. I'll also use standard thread to create my threads, and I'm going to use standard time duration because I want to put some thread sleeps in here to create pauses, and we need to specify the pauses with duration here. So let's start by creating a couple of threads. So I'm going to say here thread : spawn, round brackets there, and we want a closure in there. So a couple of pipes and probably a couple of curly brackets. So a closure, for years and years I kind of struggled with the idea of a closure. It's actually really simple. It's just a kind of thing that you can pass around to threads or whatever, which can read local variables. It's just enclosing the values of those local variables. So it's pretty simple. Let's create another one of those. And this one, I'm going to get the handle from it. So I'm going to say I'll call it receiver thread or something, or receiver th, that'll do, equals that. And then I'm going to say at the bottom, receiver th dot join. And I think, well, let's just do that and see what kind of errors we get or warnings. So I'm going to have this thread that's going to be sending messages to this thread. That's the general idea. And let's just check that this actually compiles before we go any further. I'll do cargo format, cargo format. Yeah, I've already got something horribly wrong here. I've got too many colons here. All right, let's try again. Yeah, and I forgot a semicolon there. Let's run that. That's good. Okay, and cargo build. So it's downloading the crossbeam stuff, and it says there isn't a crossbeam underscore channel, but there is a crossbeam hyphen channel. So that's obviously the one that I want. Let's try that. There we go. So it's downloading the stuff now. And there are some warnings, but these are mostly unused variable warnings. And there's going to be a lot of unused variables as I progress through this. So I'm going to just turn the unused variable warnings off. I actually keep them on when I'm coding, but it does mean you have to hunt a little bit in your errors to find actual errors rather than these warnings, which can be annoying. Let's put allow unused. Nevertheless, I do appreciate these unused variable warnings. So let's go back here and clear and try to build it again. Yeah, there's no actual problems there. Okay, so what I need to do now is I need to create a channel which is going to be used for sending messages. So it's kind of like it's like a sort of telephone connection between two different threads. You can send messages down this channel from one thread and they will be received at the other end of the channel on the other thread. So I'm going to say here, let TX and RX. Now this is just short for transmitter and receiver. I don't know why X. This is a traditional kind of notation. And we're going to set that equal to crossbeam underscore channel colon colon, and I'm going to use unbounded. So an unbounded channel is a channel that you can send, in my understanding at least, you can send multiple messages down it without the messages having to be received first. We're going to see an example of a different kind of channel, a bounded channel, a bit later on. So I can send whatever messages I want down here and they'll be received whenever they are received. We don't have to wait till one message has been dealt with before we can send the next one. Now this thread here is going to be like the producer or the transmitter. It's going to send the messages. So in here, let's put some code. Let's have a thread sleep for a start. And I'm going to say duration colon colon from milliseconds. And let's put like 2000 milliseconds or 2 seconds in there. And after 2 seconds, I want to send a message, but I want to have some kind of way of specifying what kind of message we're sending rather than just sending integers or something like that. So up here, I'm going to create an enum, and we could call it something like action or message or whatever. Let's just call it message. And I'm going to give that one variant to start with. Let's call that, let's call it terminate. So I use a capital T because it's a enum variant. And I'll just put a comma there. I'm going to have another one of these later on. So these actually have a type which we can specify. They're going to be things that can contain, or rather things that can transmit or receive a message. So I can put a colon in here and round brackets, round sort of tuple brackets, and put the types of these things in. Let's have a sender, and that's kind of a kind of generic or template type, which can contain a message. And we'll also have a receiver that can contain a message like that. Yeah, so I think that's correct. Let's go to cargo format and cargo build. Well, there's no complaints there. We will get some complaints, I think, when I get rid of this, which I'm going to do at the end. Like, I think this has a return value which we should probably do something with, but I'll just be happy for the moment if it compiles. So now let's try to actually send a message. Now the thing is, I probably don't want to just directly use tx, but let's see what kind of errors this causes. Let's say tx.send, if I remember correctly, and we want to construct a message here. Let's just say message colon colon terminate. Does that actually compile? It doesn't. What's the problem here? The problem is we don't know when this thread's going to end. You know, maybe we could put a loop in there or whatever. It could go on for hours. And meanwhile, we could drop tx, or that could go out of scope, meaning this thread now has a tx that's not valid anymore. And Rust protects you against doing stupid things like that, fortunately. So what we can do instead is just put move here. And that's going to mean that any local variables that we use within this closure are going to get moved into the closure. In other words, the ownership, at least as I understand it, will transfer to the thread somehow rather than remaining here. So tx will become invalid if we can't, for example, do something with it down here now, because it's going to get moved into this thread. Let's check that compiles. So that does compile. But the really great thing about crossbeam channel here is we can clone these as much as we like. So very often you might want to pass the transmitter around, and you might want to pass the receiver around. You might want to have multiple things that can transmit and receive on this channel. And that's not a problem because we can clone them as much as we like. So we could say here, I'll use a tuple type notation again. Let tx1 and rx1 equal, and they're going to be equal to tx.clone and rx.clone. And now I could use tx1 in here, and this will get moved, but we've still got the original tx, and we can still use it and pass it to other threads if we want to. So that ought to still build as well. Okay, all good so far. So this is sending a message, but we've got nothing receiving it. Let's work on this a little bit. This is the bit that I think I'm going to struggle to remember, but I want to have a while loop here. And what I want to do in the while loop is repeatedly check to see if any messages have been received here because they've been sent by the transmitter here. So let's say while let OK brackets message equals, and we use the receiver now, so rx1, because I want to keep this in case I want to use it somewhere else, dot recv, which is just short for receive. I think that's all we need there, possibly. Let's check if that compiles. Does it work? No. Yeah, I've just got the problem here that it's the same problem I had before. It's saying, well, this thread might outlive the value of this local variable, but that's fine. We just need to put move here so that the thread can take ownership of this. Okay, so let's try to compile it again. I'll just do a format and cargo build. Yep, and now it's fine. So what's it done? The format has done something nasty with my while loop here, but never mind. I want to put brackets in there. Enclose this in, don't I? I think I do. Yeah, so after the pipes, we can have brackets here. Did I just put that in the wrong place or something? What have I done here? Oh no, those are the brackets of the while loop. The format has really confused me now. I'm going to format it how I want it. I think once we put stuff in this loop, the format is going to be more peaceable and stop messing up my code. All right, so that's what I want. Yeah, so we've got this move. There's a closure there. Then here's a while loop, which has its own curly brackets. So we're just looping as long as this returns OK. It can return an error, and in that case the loop would stop. And if it does return OK, then we get the value out of it. And this is going to be blocking, so it's going to wait until a message is actually received. Now let's check to see if we've got any messages. And if I actually run it like this, I suspect this might just finish immediately because we're not actually checking the different values of the message. But my understanding of that is a little bit hazy, so let's just see what it actually does do. Let's do cargo run. No, it just runs. Yeah, that actually makes perfect sense. So it's just hanging around waiting for messages now. I'll just do Control-C to get rid of that. So this thread is just running and it's waiting for messages. This call is blocking the thread, but we're not actually dealing with the messages. And there's no way to terminate this thread at the moment. So thread.join just waits indefinitely in the main thread, and this carries on circling around. So here, let's have a match. I'm going to say match message, curly brackets, and then we've got this value terminate here. So I'm going to put, what's it called? Message. Let's put message : terminate. And now we need equals and one of those symbols, diamond bracket thing. And we can put a code block in here. Let's put print line, and I'm going to print out terminate message received. And then after that, we'll have, I want to terminate the loop. So let's just do break to break this while loop. Now, so what should happen now? Maybe I'll make that 3000 milliseconds. So we run the program. So both threads are going to start. So this is going to finish pretty quickly, but before it finishes, it will send a message, I think. And this is going to loop indefinitely, waiting for messages. And after 3 seconds, it's going to receive this terminate message. It's going to process it here. It's going to break this loop, and then the join will return in the main thread, and the whole program will finish. That's my expectation. So let's do cargo format again, and cargo run. So it's running and it's just waiting, and after 3 seconds, it gets this terminate message and it quits. So you can see that's pretty straightforward and it's pretty elegant. And the thing is, if you're dealing with multiple threads, you've got a lot less worries now about thread synchronization. You've not got to think about mutexes and locks and all that kind of stuff. So it's a lot easier than what I'd have to do if I wanted to send messages between threads using thread synchronization. And that's why I really like it. We also haven't got to worry about Rust ownership issues. The only thing we're dealing with ownership issues with are these transmitters and receivers for the channel, and we can just clone those and move them into our threads as necessary. So this really reduces the complexity of what you'd otherwise have to do, I think. Now, what if we want to send a message with some data? Let's have another message here. What should we call this? Let's call it get status. Let's imagine that, for example, we've got a load of oil rigs and they've all got IDs, and we want to send a message like get status 15, and it will, do whatever it does for oil rig number 15 and give us the status message telling us if it's okay or not. So I want this to be able to include an ID. So let's put curly brackets here, and here I'm going to say ID is going to be of type, let's say U32, unsigned 32-bit integer. So this syntax is kind of a struct-like syntax within that you can use within enums. So we've basically got a kind of struct here, but the whole thing is also an enum variant like terminate, which is extremely useful in this situation. So let's wait a bit. Let's wait another 3 seconds, and then do tx1.send, and I'm going to send message : what do I call it? Get status. And since this is a struct, I think I can put curly brackets there, and that has an ID field, right? So I can say ID is 123 or whatever. I'm just going to build that to check that I've not done anything stupid. Let's do cargo build. I have done something stupid. Oh no, it's just complaining that here I've not checked for the possibility of this message, and you've got to check all possibilities in a match. But that's fine. Let's put message : get status. Now what do I need here? I think I need curly brackets, and we're going to have ID in there, and then I've got a equals diamond bracket thing and a code block. That ought to make it happy if I've got this syntax correct. So I'll do cargo format, let's clear, and cargo build. Yeah, that's fine, apparently. So now we should be receiving an ID in here when we get the status message. So let's do print line and quotes, and I'll have ID received, and put a couple of brackets in there, and we can put the ID in there. Let's see if this works. So we should, this is no good, is it? I'm going to get the terminate message first. Let's move that last. So I wait 3 seconds. I send a get status message with an ID of 123. Then I'm going to sleep for another 3 seconds. Then I'm going to terminate with the terminate message. And my receiver thread should get the status message. It should print that. And then it gets the terminate message, and it prints this and it quits. So let's see if it works. So cargo format, and let's do cargo run. Yeah, so it's running and it's waiting. Then it gets the ID 123, and then it gets the terminate message, and the program quits. It's almost like magic. And I didn't really appreciate how wonderful this was until I tried writing a multi-threaded program with a data model and a user interface. And I realized how difficult that is if you're trying to pass around references to the model, which is probably not a good way to do it in Rust. And this is much nicer, and to be honest, is probably a good way to do it in pretty much any programming language. I just haven't used this all that much before. Now, the other thing that I want to show you is how we can send a request for data and respond with actual data. So this is my thread that's fielding the messages, and we can imagine that maybe has it has ownership of some data model, and we can imagine that this thread might want to make a request for some data. So here we've said get status, but we haven't actually got any status back. A simple example of what I'm talking about would be if get status actually gives us some kind of status message, or it could be a vector or a struct or anything, or some complex data structure. The principle is the same either way. So we want to send this get status message, but we want then to get a reply that includes some data. How can we do that? Well, the first thing that we need to do, I think, is give this get status a reply to field, or some kind of appropriately named field. So I'm going to say reply to here, and that's going to be of type. Now, what is it? It's going to be sender of, let's say, string. So this is something that we can use to send a reply with our message. I think I need a comma there. Let's put one here as well. And to demonstrate this, I'm just going to demonstrate sending a string, but you can very easily just put a vector in there or struct or whatever you want. Now, when we send the message get status, we have to provide a means to reply. So we have to fill in that reply to field. So what I'll do here is I'll create another channel. We'll create a channel temporarily just so that we can use it to get data, which to me seems like it might be overkill, but apparently this is the normal way to do this. So let's say let, and I'll say reply underscore tx, and we'll have reply underscore rx. You'll see what this is for in a second. And those are going to be of type, well, the rest of it's going to be very similar to this. Let's just copy that and paste this in. So instead of sender message, this is going to be sender string and receiver string, because the data that we want to transmit here is just going to be a string in this case. And instead of crossbeam channel unbounded, I'm going to use bounded 1. And that is a channel that apparently is a bit more lightweight than unbounded, and we can only send one message at a time. Before you could send another message down a bounded channel with a bound of 1, you would have to receive the message at the other end. That's my understanding. So the 1 is saying you can only send one message at a time until that message has been received. Then you could send another message if you wanted to. So we have to take this sender and send it along with the message. So I'm going to say reply underscore to is this reply tx. I think that's right. Then when we send this message, we're going to expect a reply in reply rx. So we can then say let message equal reply rx, this is receiving stuff now, dot recv, so receive, and we'll have to somehow unwrap that or something, I think, because it's going to send back a result, and the actual value we want is going to be in the OK variant of result. Let's say just unwrap, which will just panic if we get an error, but it's okay for our purposes here. Then I can say print ln and received message, and we put in there, what is it? Just message. Okay, so now it's a little bit more complicated. So as before, we're just sending get status, but along with the ID of the oil rig or whatever it is that we want to get data on or for, we also send the transmitter of a channel that we've just created just for the purpose of getting some data back. And then the sending thread will use this transmitter to send data, which we'll receive here and we'll print it here. That's the idea. So now let's take a look at the receiver thread. So that's going to get not only ID, but also reply to, and it can use that to send some data. So let's say reply_to dot send, and I'll format something that has the ID in it. So let's say format to format a string that's got an exclamation mark in it, and we'll say here everything okay with I put a couple of curly brackets in here, and we can get the ID in there as well. Everything okay with whatever ID this is. Let's delete that because I don't really need it. So that's what we're going to send, and hopefully this is all correct. Let's try to format it. So cargo format, and I'm going to try to build it and see if I've made any mistakes. So cargo build seems okay. Let's do cargo run. So we're waiting, and then we send the message, and you can see we received a reply, and we've received a reply with some data, namely this string. Then we send the terminate message, and the program terminates. So that's basically the whole thing. But one thing I'm going to do now is get rid of this allow unused and see if I've done anything that I probably shouldn't have, which I actually have. Let's do cargo build, and it's going to say, I'm going to get some problems here. So let's just work through them. So it says unused imports, bounded and unbounded. Did I really not use those? Ah, yes, because I referred to them via crossbeam channel. I could just get rid of that because I included them in the use statement at the top. So let's get rid of crossbeam channel there. I'll just use bounded and unbounded directly. Then we've got on line 20, there's a result that must be used. So we're ignoring the result of send here. So on line 20, what I could just do is I could say let underscore equal that stuff to say basically ignore the return value of this. But I think what would also work is I could also probably do unwrap, and then we're unwrapping the result, and I'm still basically ignoring it, and that will panic if there's an error, which is fine for this little app here. Okay, let's see if that was okay. Cargo build, I've got a few more ignored results, I think. So yeah, we've got the same problem wherever we do send. So on line 31, there's a problem. So here we could do dot unwrap, for example. And what else? Line 42, there's a send. Let's try unwrap on that. Unwrap. What else? We've got 48 with the join. That's the same deal again. So unwrap. Okay, let's try it. See if I've got all of them now. Cargo build. Yeah. And cargo run. And fingers crossed. Yeah. Sent the get status message. We got this status for the ID that we sent, and it terminated. Phew. So that's the whole thing. It's a bit complicated, but if you try it out yourself, if you go through it step by step, as I have done, I think you'll see how it works. And although cross-thread messaging kind of sounds a bit complicated just in itself, this is really the only really feasible way I've found of dealing with a situation where I have a data model and I have a user interface that wants to write to the model and also read it, and I have another thread that wants to read the model. Everything else that I tried so far was actually more complicated than this, believe it or not. Okay, so anyway, that's it for this video. I'm going to put a write-up of this on blog.caveofprogramming.com. I'll put a link in the description so you can click it. And if you go to that, you'll see, some stuff that I'm going to write in a blog post. And I'll also put there a link to the GitHub repo so you can check this code out online rather than having to get it all from this video if you do want to try this for yourself. So yes, I can say that I am now a fan of Rust, and I probably will be using it instead of C for most things that I previously would have used C for. Anyway, until next time, happy coding.